So for those of you who I hope aren't lost, this is the robot construction webinar. So I hope you're here for that. The first big pointer that Patrick and I can give you is obviously this is a competition. And one thing about competitions is that they are graded. So make sure that you check the evaluation criteria. Last year, Patrick and I did a pretty good breakdown of how to look over the evaluation criteria and what you should be looking for in your robot. So we're not going to be taking the exact same approach this year because we've already covered that. If you want, go over it in the participant portal, look up the rule book, go to the end where the appendices are, and you're going to see the evaluation criteria for your robot. So go over each pointer and decide what seems relevant to you and what you need to be looking for systematically throughout the construction process.
All right, so I'm going to go over the principles of robot construction. So there's 7 basic principles that we'll be going over in this webinar. So preparation and communication, choosing materials, tools, and their alternatives to give you guys an idea of what you can do with tools, because you might not necessarily have all of the tools that you want, but there are ways to get around that. We'll go over a bit of tool safety. We'll go over some basic components that you would most likely see in a robot. Some considerations for when you're assembling your robot, and then we're going to finish it off with Murphy's laws of construction.
So the first pointer that we're going to go over is preparation and communication. There are 4 main principles that we'd like you to consider, especially, and if you have others, of course, bring them in on your own team, like with your own team. The first one is to have an effective method of communication. So contrary to the other teams, you're going to have a lot of very specific plans that you're going to be drawing out. Hopefully you have a design ready to go, whether it's drawn by hand or whether you did it with AutoCAD or something. So make sure that you have a platform for general communication, just to keep in touch with each other, have an open communication going to, for example, say, hey, where are you on this? When are we meeting up? All of that all the general questions you're going to be having to talk to each other. Also have somewhere where your schedule is. So it's always a good idea to have everybody be aware of where everyone is throughout the whole process. And you want to have another place, usually a Google Drive would be good for keeping specific plans, links to YouTube videos, things like that. Then you're going to want to establish a schedule. So the best way to do this, in my experience, is always to overestimate the time it's going to take you for each step or each part that you're going to be constructing. Make sure that you give yourself some leeway, because the tighter you are on your schedule, the more you're going to feel rushed and the more likely it is that you're not going to be ready in time. So give yourself a lot of leeway and make sure that directly on your schedule, you write down who is responsible for that component. Because one thing I found is that a lot of teams, what they'll do is they'll say, okay, well, these are the steps we need to take to build our robot. And then everyone is just assuming that someone else is going to be doing it. So in your meetings, make sure you're saying, okay, this is what needs to get done. Who would like to take on this responsibility? So it's always a good idea to have a moderator at your meetings to say, okay, who's ready to take on this responsibility? And then delegate from there. Of course, you guys are going to be working as a team. Of course, there's going to be more than one person working on each part and each step, but it's always good to have a go-to person to make sure that all of the information is centered around somewhere and someone is taking responsibility. The next pointer is to know the strengths and the weaknesses of your teammates. So everyone has something to offer and nobody has absolutely no skills. That doesn't happen. If you're coming in and you want to participate, you do have something to offer. So for someone, let's say, who's better in electrical, of course, you're going to put them into something more electrical because you're going to want to use your strengths. But that doesn't mean that you can't partner them with someone who has less experience, especially when you're considering the long-term game, because a lot of schools are going to be participating year after year. If you end up in a certain year where all of a sudden you have nobody who has experience in the electrical field, that could be a problem. So make sure that some people who have an interest in learning things are partnered with people who are already strong. And that way you'll get to share your knowledge and you'll be able to build off of others' strengths. The last one is make sure that you are consulting each other. So, of course, no team can progress without having open communication, without knowing where everybody is. If ever, because things happen, we all know this, life will get in the way at times. If ever you cannot complete your task for your team, you have to be transparent with them. You have to let them know that you will not be able to complete that task, and make sure it gets delegated to somebody else.
Just a little point I want to add to that is that for communication and preparation, if you do have any other questions, we did do a workshop on team management, which is available to view online. Okay, so one major consideration when you're building your robot is choosing materials. You have 5 different things that you have to keep in mind generally. Their strength versus weight, cost versus availability, ease of use, so how easy it is to actually use and cut and bend, etc., the material. The aesthetics, because you do get judged during the competition on things like your wire management and how well things look, not just how well things are designed. And the sustainability is a point that's getting more and more important as things go on in the world. So the 3 major materials that we see in this competition usually is wood, steel, and aluminum. Here I've put up a graph just showing red is not the best, yellow is okay, and green is better. So wood, it's a very solid material, but it's also very heavy, and it has a tendency to crack under stress. It's very cheap, and it's very available. It's easy to find and easy to use, but aesthetically it's not very good. And in terms of environmental impact, it's not bad because it is a renewable resource. Steel is, again, very strong, but extremely heavy, and also much more expensive and much harder to find relative to wood. It's less easy to work with because you have to weld. You usually have to get more specialized tools, like different drill bits, different things to cut the material. It's not just anything goes. It does look very good, usually the final product. And in terms of an environmental impact, it's not the best because it does take a lot of effort to produce, and it does put out a lot of carbon into the atmosphere when you're doing those things. And finally, the material that we see more and more during the competition as it goes on is aluminum, specifically extruded aluminum, but any aluminum will do. It's very solid and very lightweight. It is a little bit harder to find, but there are specialty manufacturers in and around most cities, which I'll tell you how to look for that later. And it's relatively expensive, but it is reusable. So that is an important point to keep in mind. It's very easy to work with. In most cases, if you have what you need to cut wood, you can cut aluminum. A lot of aluminum can be cut with very simple tools and worked with very simple tools. It's a soft metal. And then aesthetically, again, like steel, it makes a very pleasing robot. It looks nice. The judges usually appreciate them more. And then from an environmental aspect, aluminum is infinitely recyclable. So it's a great material if you're looking for something that's environmentally conscious. So for finding tools, this is the 2 things that I hear the most when people are talking about their robots generally is A, that they don't have a big budget, or that they don't have the tools that another school may have to be able to put out a great robot. I think that a lot of people have a misconception where they think that cheap tools are bad tools. That's not the case, not all the time anyway. Like, for example, Mastercraft, which is a brand available at Canadian Tire, has a lifetime warranty on most of their tools. They're cheap. You can find them on sale very often. But with that lifetime warranty, if they ever break, you can just go to your local Canadian Tire and have a new one pretty much on the spot. Another brand similar to that would be the Power Fist brand, which is, again, lifetime warranty and available at the store Princess Auto. It's a more car-focused store, but it is a store that you can find in Quebec and in other parts of Canada. And the other thing is you don't always need power tools. So a lot of people, they think that they need a drill press and a circular saw and an electric sander and things like that to build a good-looking robot and a robot that's solid. That doesn't mean it. It's what's important is more the effort put into it than the tools that you have. You can get away with hand tools, but if you don't have the budget for things that are expensive, you can get really good quality out of tools like Ryobi, DeWalt, and the Mastercraft Maximum line of electric tools. Ryobi, for example, they have something like 200 different tools that fit the same battery, so that's a very good tool for a budget-conscious school. They even have a battery-powered soldering iron, which can be very useful in a competition like this for repairs. And lastly, used tools are something that's very underappreciated. You can find them very easily through garage sales, through Facebook Marketplace, through friends. You know, everybody has that grandfather that had, you know, a garage full of tools that passed away that they don't know what to do with anymore. There's lots of great ways to get tools either cheap or free. And 99% of the time, those tools are just as good as what you're going to find in the store. Although there is one tool that I would highly recommend for any team starting out is a good bench vise. So something that you can screw down and clamp materials in, like a 4 or a 6 inch size, because that will allow you to much more easily cut materials and work with materials, but also do it in a much safer manner. You won't have to have people like sitting on a piece of wood while somebody else cuts it with a saw, for example. You have that extra security. Okay. Pour trouver les matériels, des aluminium, puis le bois, puis le quincaillerie, ça se trouve facilement à des places comme Home Depot, Renault Depot. Sinon, en ligne, des magasins comme Ackland Granger puis McMaster-Carr. Et sinon, c'est souvent facile de trouver des shops, specialty shops, comme par exemple Aluminium, c'est chez des magasins comme Fastech, Hydroaluminium, Illumine, puis Langevin Forest pour du bois. Côté électrique, tu peux trouver souvent 99% de tes matériels sur Amazon, Robot Shop, Vex, or eBay and AliExpress, depending on what you're looking for. Electronic stores like Addison, Abra, and Canada Robotics are also good places to find electrical materials at a good price with relatively good quality. And one that's usually overlooked for electrical is automotive stores, because most of the wiring that you're doing on your robot is going to be 12-volt wiring, which it's very similar to the wiring that you'll find in cars. So at automotive stores like Napa, the Canadian Tire parts counter for cars, you can find things like 12-volt wiring, spade connectors, terminal blocks, everything that you need to do your wiring for your 12-volt motors. And lastly, for your Lexan, plastics, things like that, again, you can find them at Home Depot, Renault Depot, places, building centers like that, Canadian Tire even. There are specialty suppliers, which you can find by just Googling in your area. And one thing that I prefer is recycling centers. Personally, old election posters and cardboard are my bread and butter for building robots, not because it's a good material to build a robot with, but because it's a great material to prototype with, which I'll talk about in my next slide, which is CAD, Cardboard Aided Design. So cardboard is pretty much free. You can go to any Metro or Rona or Costco and find it in a recycling bin in the back, usually in very large sizes. It's extremely easy to work with. It cuts with pretty much anything that has a sharp edge. And it's extremely fast to quickly figure out a design and see if something will work and to give you an idea of the size. So in the photos that you can see on these slides, one of them is a robot built basically entirely out of cardboard with some electric motors taped to it. That's a good way to figure out like your sizing and things like that. And the other one is something that I did a few years ago when I was participating in the competition. It's a top view of a hopper that we were working on, trying to figure out what volume hopper would be the best, what design, what sort of a feeding system would be best. And with cardboard, you can cut out pieces and literally just move your tape slightly and figure out exactly the angle that you want before investing into more expensive materials. Okay, so I'll go over the tools now. There's 5 categories of tools that you'll see most often when doing robotics. They're cutting, measuring, assembling, clamping and holding, and wiring tools. For cutting tools, the most common one you'll see is a chop saw or a bandsaw. That's the saw that you cut when you pull down on, or the saw that you can push your object through it. The alternative for that would, if you're looking for a good budget option, would be a hacksaw or a wood saw, something like in the photo with just a fixed blade that you can run back and forth by hand. And then you would have your press drill, which the alternative would be an electric or even a hand drill. I've seen people drill holes by hand, and a good drill bit set. Out of all of this, I think that the most important thing would be a good drill bit set, because the price difference between a cheap set and a good set is not that large. You don't need a cheap set with 600 bits. A good quality set with 50 bits will get you much further. You won't have to constantly be breaking them. Cheap bits, they don't drill as well. They take longer to drill, etc. In cutting tools, we also have generally utility knife and scissors. This is good for cutting cardboard or Lexan, things like that. And then a metal file and sandpaper. When you're working with metal like aluminum or steel, you're going to want to sand and file pretty much every edge that you cut, because it can get, I don't want to say dangerous, but it gets to the point where working with the material isn't as fun, because you're more often having issues with getting small scrapes, small cuts, and it's just safer for everybody and also looks nicer, the finished product. Measuring tools. These robots aren't exactly NASA specs, so you don't need anything complicated. A measuring tape, a ruler, and an adjustable square with a bubble level on it are more than enough for 99% of what you're going to be doing. Sometimes you want, say, a protractor as well, but besides that, we don't need them to be exact measurements. If they're within a 16th of an inch, generally it's fine. For the assembly tools, you have your impact driver or a hand screwdriver, sorry. A good set of pliers will get you a very long way. Like in the photo, a basic 5-piece set. So your needle nose pliers, diagonal cutters, some blunt nose pliers, and a pair of channel locks. That will get you pretty much everywhere you need to go in terms of grabbing things. A basic wrench or socket set will also help a lot with the construction of your robot, because you're going to be using a lot of nuts and bolts. A hammer and a mallet are also great, because this can be used not only on the robot but also with the kiosk for when your cuts are not exact or you need to just push something into place. And then Allen keys and a basic screwdriver set. These are also great because with the robot, generally a lot of the fasteners that you'll use will have Allen heads or things like Robertson square heads. So having a good variety of them is a great idea, and they're not expensive to purchase either. For clamping tools, like I was mentioning earlier, a bench vise is a great option. It's a helping hand. It's great to put pieces into to assemble them without having to worry about them falling or scratching. The alternative would be the various vice grips. They don't only come like what you see in the photo. There's hundreds of different styles of them, or a C-clamp. And then finally, a corner clamp can be useful for making sure that your robot, the frame or whatever you're working on, is nice and square. It's a nice 90-degree angle. As a bonus, the C-clamp and corner clamp can also generally be repurposed for kiosk work. And then one of the more important sections would be wiring tools. This is something that you don't necessarily think about when you're doing the plan for your robot, but wiring, I would have to say, is probably one of the most important aspects. So a good set of wiring iron, soldering iron, wire crimps, a pair of helping hands, things like that will help a lot, especially a soldering iron. If you're going to be soldering your connections, they're not that expensive. Having 2 or 3 sets can be a really good idea. It'll help more people do it. It'll be faster to put your robot together, but also it's a lot easier to teach somebody when you don't have to be sharing the same tools. So just a quick bit of basic tool safety. So you have to keep in mind your tool should be in good shape. It shouldn't be dirty. It shouldn't have a cracked handle. It shouldn't have a broken point on it. It should be the right size. There are different sizes of tools like screwdrivers and saws and hammers. If you're using a giant screwdriver for a tiny screw, you should probably use something else if you are able to. It's a good idea to make sure it's clean and maintained when you put it away because, well, first of all, nobody likes to use a dirty tool, but also cleaning and maintenance will usually give you a good idea if the tool is in good shape. It'll give you a chance to notice those things like cracks and things like that. Only use tools for what they're meant to use. So a screwdriver, a big flathead screwdriver is not a substitute for a chisel. And that's the biggest one that I see, the biggest error. The pointy tools, just like when you were taught in kindergarten or by your parents, like scissors, they should always be carried with the point down, not in your pockets, because if you trip and you fall, it's not fun. And if you have, say, an X-Acto knife, make sure the blade is retracted when you're not using it. I see that often where people leave fully extended X-Acto blades laying on the floor where it's easy for somebody to just step on it or put their knee on it. Wearing appropriate clothing is a big factor as well. Loose, baggy clothing around things like a saw or a drill press is a good way to have an accident. Keeping your work area nice and clean, keeping excess materials off of the floor is also a great way to make sure that you're not only keeping your space safe, because you won't have the risk of tripping over things and falling on things, but it also helps you to build your robot because you'll be able to see what you have. You know what you're working on. You're not constantly digging through a pile of material to find that one bolt or that one hinge. And then finally, wearing the proper personal protective equipment, so things for your ears, eyes, your hands, gloves, is important whenever you're using any type of tool. But don't forget the other people in the room. Just because you're safe with your personal protective equipment doesn't mean that the guy 2 feet away from you is also safe without it. So every team should have a basic first aid kit. This is we go over this in the rulebook, but basically a pack of adhesive bandages, some gauze, a little first aid manual, a cold pack, antiseptic wipes, things like that. It's all good things to have on hand, and also make sure that they are not post-dated, they're not expired, because they do go bad after a certain amount of time. Generally, if it's 3 to 5 years old, it's a good idea to replace the kit.
So now we're going to move on to linking component. Essentially, when you're going to be building your robot, you're going to end up having to put pieces together. That's a given. There are certain questions that you should be asking whenever you're getting ready to put 2 pieces together, whether they're on a small scale because you're just putting 2 pieces of metal together, or whether you're ready to attach a subsystem to the main body of your robot. The first question you're going to ask is, how are you going to do it? So is the connection going to be direct or is it going to be indirect? Comme vous pouvez voir, les connexions qui sont directes, c'est 2 morceaux qui rentrent parfaitement l'un dans l'autre, puis ils n'ont pas besoin d'autres moyens pour se tenir ensemble. Donc, des engrenages, ça serait un exemple parce que oui, ils fonctionnent ensemble, ils sont connectés, mais ils n'ont pas besoin d'un lien externe pour le garder ensemble. Ils ont besoin d'un lien pour rester dans leur autre mécanisme. So you're going to have usually a bolt or a screw going into your gears, but the gears connecting to themselves do not have anything connecting them other than each other. Comme vous pouvez voir, vous pouvez aussi faire des morceaux de métal ou de bois qui sont parfaitement construits pour juste glisser l'un dans l'autre. Et normalement, quand vous faites des connexions comme ça, c'est plutôt difficile de les enlever pour de l'entretien ou des affaires comme ça. Il faut aussi s'assurer que c'est fait parfaitement. Donc, si jamais il y a un petit peu if there's any wiggle room, chances are that it's going to wiggle. So you want to make sure that anything that you're doing directly is perfectly fitted, or it doesn't need to be exactly in place. If it wobbles a little bit, it's not going to be a big deal. Si jamais vous voulez faire des connexions indirectes, donc avec un autre moyen de les connecter, les deux meilleurs exemples en robotique, ça serait avec boulons et écrous ou avec des vis. One thing I noticed is that when I first started robotics in high school and I asked the difference between a bolt and a screw to my build captain, I did not get an answer. They could not tell me what the difference was. And I think that it's very important when you're building things to understand what you're using and why you are using them for that purpose. So, one of the big examples that I'm going to be highlighting just to give you an idea of what you should be looking for is when you're looking at a bolt or a screw. For a bolt, the hole that you're putting it into does not have to be threaded, and the screw, it does. Whether those are advantages or disadvantages depends on the situation. I would say that for a bolt, the fact that it cannot create its own fixture can be a disadvantage because you're going to need to use a drill in order to create the hole beforehand, or some sort of if it's a really weak material, you can use a punch as well. A screw, depending on the type of screw, can create its own fixture. So a self-tap screw is a good example of this. It can go directly into metal and bore itself on its own, creating its own threading. For non-self-tapping screws, you're going to need to create those threads beforehand. Bolts are in general very solid. Screws are only as solid as the material allows. So as you can see from the picture, the pressure going against the screw is only the material. So if you have a weaker material like cardboard, a screw is not going to cut it. A bolt in that case probably wouldn't either, because on the other side, that the nut that's holding it in place is probably going to tear right through. So you're going to need a supportive element to it. Next, the bolt is removable, and the screw has limitations to how removable it is, and I'll go over that a little bit later. For a bolt, you'd need two-sided access because you need to put in a nut unless you can get perfect threading into your material. So if your material is threaded for a bolt, then yes, you can use it without a nut. But in general, when you're going to be building in robotics, you're going to be using nuts and bolts together almost all the time. And a screw, it only needs one-sided access. So especially for things, even if you have the room on the other side of that second material, if you know that that second material is going to be leaning up against something where you won't be able to get a wrench in, I won't recommend using a bolt if you need it to be removable. Next slide. For components that are flexible or rigid, this is more talking about the actual material itself and not whether it's supposed to move. So I gave two examples in each case. The first one on the flexible side is coroplast, so that corrugated plastic. It's a very flexible material. Whether it's supposed to move, that depends on its function. So I had one of my robots that had a flap where, yes, we did want the plastic to be able to move. And then we had on that same robot another spot where the plastic was actually serving as a wall, and so we did not want it to move. So the flexible versus rigid is based on, is that material going to bend, or is it going to remain completely solid the entire time? When you have materials that can bend like coroplast and you want to put them, attach them to something else, especially when you're attaching it to something stronger, you might want to use reinforcement. So as you can see with the coroplast, with that screw, there is a washer to spread out that pressure and make sure that when you are putting your screw in, you're not just making a bigger hole and that it's just going to go right through and your piece is going to come off, because you don't want to get that junk penalty and you don't want your robot to break. Another example would be mobility and friction. When you're putting wires on your robot, you're going to want to hold them down somewhere. You want to make sure that whatever they're being held down to is not going to create too much friction on those wires, especially if you're bunching many wires into that same holder, whether you're using a tie wrap or whether you're using a proper one. It depends on what you're looking for, but make sure that the friction is not going to eat away at the plastic. Make sure that if there is heat in that area, that the heat and the friction are not going to wear at that plastic, because if two of your wires end up getting stripped and come into contact with each other, that could create big problems and it could create a big boom. You don't want that. Onto the rigid materials, you're going to be seeing some can move. So my example for the rigid materials that can move is a bearing, but it's a gear bearing. So the materials inside are all solid, but it can still move. So rigid materials can undergo motion. And when they do, you want to be aware of jamming or breaking whenever it's a rigid partial connection. So if those gears are in any way not perfectly fitted to each other and they're undergoing really intense pressure when they're trying to move, they will break because they're rigid and they don't have that elasticity to be able to undergo that pressure. And when you want your rigid pieces to remain in place, you want to make sure that you fasten them as tightly as possible without breaking them. So don't overdo it on the screws. Some people, I see them like trying to get it as tight as humanly possible, and then they either end up breaking their screwdriver or drill bit, or they end up breaking their material. So make sure that you're making it nice and tight, but don't break your material either. So yeah, it's always make sure that you're considering it's based on the material. Use reinforcement when you need it. Even with rigid materials, sometimes you're going to need a little bit of reinforcement when it's something like aluminum that has a little bit of flexibility to it because it's malleable. So use proper reinforcement when necessary and reduce friction where possible. The next one is complete or partial. So this is what I was talking about with, are your pieces moving? So this has nothing to do with the material itself. This has to do more with the function of your pieces. So with complete links, they're usually found more in your framework in your robot. So when you're building your base, you're going to want to make sure that those pieces are not moving. When you're making your systems, those are more likely going to be your partial ones. And a good rule of thumb is that usually partial connections will come with a motor because you want them to move. And the best way to make something move is with a motor, unless it's something that's more automatic. When it comes to your framework, you're going to want to make sure that your frames or structures are very solid. So make sure that the pieces don't move or wobble. Test them a little bit, push them from every angle, and make sure that they are staying in place the way that you intended them to. When it comes to partial links, you want to make sure, like with that linear slide, so when you have a piece going up and down, you want to make sure that the parts are not sticking and that they're not eroding onto each other either. In general, if you notice that your pieces are sticking a little bit too much, check to see if there's any glue or anything that needs to be washed off. And if they need extra lubrication, then you can use WD-40. That's like the golden standard. Anything that you can use to get those pieces like less grinding against each other. With bearings, so those are something that are always important and I find very often underused. Bearings are going to allow you to have a smooth and supported rotational movement because it's a piece within itself. It's its own mechanism, but you can integrate it into your robot and make sure that everything is rotating as smoothly as possible. There's no rubbing against each other. In general, if you get a good quality bearing, there isn't going to be that unnecessary friction and things are going to rotate a lot more smoothly. The bearing itself, you want to make sure that it's not broken. And when you use any sort of partial connection, you want to make sure that they're well calibrated. And the good thing about bearings is that they already come properly calibrated. So you don't really need to consider it too much. As long as you are putting it in at the right orientation and it's well supported, your bearing should allow for really smooth 360 movement. Whenever you're introducing partial components, make sure that they're as accurate as possible and that your programmer feels comfortable with what you've done. Because if your programmer is not comfortable with the connections that you made in your partial linking components, and they don't feel like they can program something that will allow for that, think of a way to change up your system. And make sure that you have a fallback in case of minor deviations over time. So especially with competitions where accuracy is important, you want to make sure that all of your partial components have a limit and that that limit is respected. If there's any sort of deviation, make sure that it's accounted for in your plan. The next one we're going to be going on to is the removable or non-removable. These ones are the ones where maintenance comes into play. One thing that I want you to always consider is, do I need access to something that is in this system or behind this system? Because a lot of people think, okay, well, this one I have access to it, it's all good. And then they don't realize that there's something behind it that could break. And now you can't get to it. And you're trying to wiggle through with all of your tools and it's just not working. When it comes to non-removable connections, I'm giving you guys two examples, one that's more mechanical and one that's electrical. So with non-removable links in mechanical, you're going to see welding. So like Patrick said, some metals are better for welding. I don't recommend doing it with aluminum necessarily, but or at all. But you might weld some of your materials. Make sure that you're doing it properly. If you are, I recommend having it done by a professional, especially if you're in high school. Don't weld on your own. Don't try to do it. And please do not weld with solder. It's not going to work. Don't try it. It doesn't do well. If you are soldering, it should be for wires only. One thing I want to point out is I did put in a picture of proper soldering, and there is a reason that you're going to solder end to end and not do that thing where you line the two wires up side by side and then twist them like you would with une marette. The reason that you do that with soldering is because the solder creates a very solid joint and your wires are flexible. So if they're head to head, you want your wire to stay straight. If it's staying straight, then there's no tension on that little end that you put the solder on. Whereas if you do that side to side and then your wires, those two ends are going in different directions, you're pulling on those two sides and your wiring is more likely to break if you do it that way. So if you're planning on soldering, make sure that you know the proper way to do it and that you're making these considerations. With the non-removable, actually I switched that on the slides. With the removable components, bolts and wire terminals are your best bet. So bolts are always removable. You can take them off because as long as you can access them. So with a good wrench and either a screwdriver or a ratchet, depending on what kind of bolts you have, you can take them off as many times as you need. And with wire terminals, all you have to do is clip them into each other for the ones that are directly clipped, or if they're going onto a terminal bar, you can screw them in and then take them out, and you don't have a problem with needing to cut wires halfway through. You can switch things out a lot more quickly when things are removable. The reason that I put screws sort of in the middle is because screws have a certain limitation when it comes to this. If you consistently put in, remove, your screw is going to end up becoming threaded. So that material, those threads, they're going to completely just erode. You're not going to have them anymore. One solution that I used to use with this when I was in robotics was we'd always start off with a number 8 screw. And then once we realized that the hole was sort of stripped, we would move on to a number 10 because it's a little bit bigger. So it'll rethread that hole in the same spot. Just don't do this too often, because especially when you're working with limited space, you don't want to have a bunch of big bulky screws everywhere. You also don't want to take advantage of this too much because you are going to be wearing down on your material. If the hole was already made for a number 8 and that threading isn't completely stripped and then you put in a 10, you also risk not having it go in straight like you wanted it to. It could deviate a little bit. So just be careful when you're doing that, but it is a solution when you don't need things to be as like cut and dry clean. I also want to mention that the difference between screws and bolts, because yes, bolts and nuts can get stripped as well. The big difference between why I consider bolts to be always removable and screws only half the time is because the screw is going into the material and the bolt is going into the nut. So the bolt is not ruining the material you're working with. You can switch out the bolt and the nut and keep your system the same way it was with the same materials. Whereas the screw, if you damage your material, you need to replace that material. And that's about it for removable and non-removable. I hope that was just switch the two at the top. When you're building, a couple things I want you to consider is, first of all, the order of assembly. So like I said, especially when you're working with removable and non-removable links, please do not work on something and then put it on your robot when something behind it is not done yet, or when you know that you're not going to be able to continue something that you hadn't finished. Look at your design when you're building. Make sure that you're not blocking yourself, and consider the orientation. So when you're building one of your systems that's going to go on your robot, think about which side you're putting the bolt and screw on. Can it work in another orientation if when you're putting it on the robot, something else is going to be blocking your access to it? So make these considerations in your design. And then while you're building, reevaluate constantly and say, okay, am I going to be able to access this if something goes wrong? Another thing, do not leave your wiring to the end. A lot of people do this. They say, okay, I'm going to figure out wiring at the end. It's one of the easiest things. Wiring can be easy, but only when it's done well and when it's always being thought of. So as you're going along, make sure you're thinking, where are my wires going to be in all of this? Because when you have systems that are going into extremities, if you have an arm on your robot, if you have something that's moving along a shaft and has an extra component at the top with a motor, what is happening to those wires? Are they getting stretched out? Are they getting coiled? Can they get stuck in something? So you want to be keeping them out of the way of your moving systems and always have a little bit of leeway so that if something goes wrong, you have that little extra, but keep that extra out of the way. So tie it and leave it on the side, but have it there just in case you need it. The next one is preserve and reuse your materials. So a lot of teams have problems with their budget and getting really good materials for longer. And this kind of plays into the cost benefit analysis of, should I get a more durable material or should I get a cheaper material? This goes into what you see as being more of an investment. So generally your frame is not going to have as many holes in it. You want to have something that's going to be a bit more solid because you will be able to reuse it. Whether you have to cut down the corners because you made too many holes at the linking parts and then use the more central part that hasn't been tapped into, that's fine as well. One thing that I did in my last year and that I found worked really well with my team, we didn't have necessarily the budget to buy materials to practice on. Practice is going to make you a much better builder. So when you have your robot from the year before and you see a piece that is absolutely destroyed, you cannot use it on another robot, put it in a box that people can practice on. Whether it's just practicing drilling straight holes, whether it's practicing sawing in a straight line, even your wires, those wires that are completely frayed are the best ones to practice soldering on because you're going to have challenges when it comes to wire connections. And practicing on different types of wires, different levels of ratty, it's going to make you a better builder in the long run. So use those dead materials for practice so you don't have to buy ones that are just going to go in the trash anyway. Make sure also that you are testing as you're going along. Every single phase of construction, you need to make sure that your parts are working. It's going to allow you to find problems a lot earlier. Maybe something didn't work the way you initially planned in your design. Something came up. Nobody gets it right the first time around. Or at least not that I've ever heard of. Everyone has to fix something somewhere along the line, and you'd rather know that sooner than later. It's going to also prevent you from having to completely take apart your robot somewhere down the line where you're not going to have the time to put it all back together again and rethink your entire design. So consistently test your robot. The moment that drive system is up and running, get it tested. Make sure it can handle the load. The moment you add something to your robot, test the other systems that you've already tested just to make sure there's no conflict, because that can happen too. And the last point is use your resources. Your resources can come from everywhere. You can have tutorials that we've provided with the CRC. We have the wiki. We have YouTube. YouTube is one of the best places to find different ways to build things. And I find looking at the comment section on YouTube videos will give you an idea of whether it's reliable or not, because people have a lot to say about reliability, and it'll give you an idea of whether that's something that's gauged to what you need to know before you spend half an hour watching a tutorial. And one thing I can say from experience is definitely use each other, because your team is probably your most valuable asset when it comes to learning. I know that for me, Patrick and I were on the same team, and I learned so much from working with him. He taught me almost everything that I know. And not to embarrass him, but a little bit. But yeah, no, you learn from your team a lot. And whether it's because they question something you thought you knew so well, or whether it's because they're teaching you something entirely new, you're going to learn from each other, and you're going to learn better ways to do things or ways that are creative that work in specific situations. So use each other as much as possible.
Okay. J'aimerais ça juste passer un petit peu de temps sur le calibre du fil, parce que je trouve que le filage, c'est un des aspects le plus importants dans le robot, que c'est souvent le plus oublié. dans la compétition, on a un limite de 30 ampères. Ça veut dire que total, le système 12 volts, ça ne peut pas tirer plus que 30 ampères parce que tu as soit un breaker ou un fusible de 30 ampères qui va soit tripper ou blow à 30 ampères. Mais dans mon expérience personnelle, je trouve que faire le système pour 30 ampères, c'est pas assez suffisant. Il faudrait penser plus à le oversize un petit peu pour être capable de prendre 40 ampères pour que tu es certain à 100% que tout va bien fonctionner. Qu'est-ce que j'ai mis dans le slide, c'est une bonne indice. Quand tu vas calculer ton filage, il faut toujours garder dans la tête que le plus long que tu fais le fil, il faudrait que tu fais plus épais aussi. The 10 amp wire at 2 feet, you can get away with a smaller wire that's 16 gauge, but once you get to say 20 feet, you have to go down to 10 gauge. So usually I like to oversize the wiring in a robot to 40 amp specifications because like that, you know that no matter how long your wire run is, you're never going to have an issue. I even went to the point of when we were using the Makita 12-volt drill batteries a few years ago, I went to the point of taking apart the drill battery housings and redoing the wires on the terminals themselves because the wires coming off of the terminals were something tiny like 16 or 18 gauge. And I went to the point of putting 10 gauge to be sure that they would be able to pull the full maximum amount of amperage through them without ever overheating. We had a couple instances of robots catching fire in the last few years, so I think that it's a very important point to go over that your wiring has to be minimum spec to 30 amps, if not more. Your low power items, so your servo motors, your VEX motors, everything that works off the CRC Arduino can get away with between 16 and 22 gauge, depending on what it is. But all the high power items, personally, I wouldn't go any smaller than a 14 gauge wire. And this is something that I saw a lot of teams struggling with over the years is people putting 16 gauge wire on a drill motor and having the wire either get very, very hot to the point of burning or get hot to the point of changing the color of the insulation on the wire. So always remember that when you're calculating your wire length in feet, you have to do the full length. It's not just, okay, I have my battery here and my motor here, they're 2 feet apart. Okay, I need to calculate for 2 feet. It's the length of the positive and the negative wire together. So that'd be a 4 foot total run. These charts like this can be found online, and you can even find calculators to figure out how many amps a certain motor is pulling if you want to double check. But because wire is reusable and wiring for this type of application is relatively cheap, you can get, say, a 50-foot roll of 12 gauge wiring at a store like Addison or Abra for $15 or $20. I just prefer to go oversized because like that you won't ever have any issues. Like Sarah said, make sure to add a little bit of extra wire, generally 10 to 15%. So if you have a 6 foot long wire, having 6 to 8 inches spare will always be a good thing because you can cut the ends to redo the connections if you need to in an emergency, but also because servicing that part will be much easier to remove it and then take off the wiring.
Donc, la dernière chose qu'on va discuter, c'est les Murphy's Laws of Construction. So basically, for those of you who don't know, Murphy's Law is anything that can go wrong will go wrong. Pour les applications de la construction en robotique, j'en ai découvert 4 dans mon expérience. La première étant, si ça peut briser, ça va briser. Donc, assure-toi que tu optimises la force de ton robot. Assure-toi que tous les composants que tu as construits sont vraiment forts et sont capables de résister à plusieurs heats, à plusieurs différentes forces du monde extérieur. Assure-toi aussi que tu es capable d'avoir accès à tes composants parce que si c'est capable de briser et tu n'as pas accès, c'est un peu détruit pour la compétition parce que ça va prendre trop longtemps pour complètement détruire ton robot pour pouvoir le reconstruire. Donc, assure-toi que tous tes composants essentiels sont accessibles. La deuxième, c'est que si ça peut mal fonctionner, ça va mal fonctionner. Donc, assure-toi de vraiment, avant de commencer ta construction, dès que tu as fait ton design, va voir ton programmeur, discute, est-ce que tu te sens à l'aise et capable de programmer un robot avec ses objectifs, avec ses capacités-ci. Si ton programmeur ne se sent pas à l'aise de faire ça, ça serait peut-être une meilleure idée de soit demander est-ce que tu te sens à l'aise de l'apprendre ou est-ce qu'on devrait le changer. Donc, communication avec ton programmeur, c'est essentiel pour éviter des robots qui ne fonctionnent pas ou qui arrêtent de fonctionner plus tard. Et assure-toi de prévenir un système qui va mal fonctionner ou qui va that's going to fail. If your system is too complicated, then find a way to bring it down a notch, find a way to make it a little bit simpler so that it's not going to malfunction. La troisième, c'est si tu peux manquer de temps, tu vas manquer de temps. Donc, laisse pas les choses à la dernière minute. Si tu laisses tes choses à la dernière minute, non seulement tu auras moins de temps, mais tu auras beaucoup plus de stress. Et le stress, pour la majorité des gens, c'est pas bon pour le cerveau. Ça t'aide pas dans ta construction. Tu as plus de chances à faire des erreurs que tu aurais pu attraper sinon. Donc, garde beaucoup de temps pour faire tes choses comme il faut. Garde beaucoup de temps pour reviser ton projet et pour vraiment bien faire tous les aspects. Et la dernière, ce qu'on a appris un peu trop souvent, c'est que si tu peux te blesser, tu vas te blesser. Donc, assure-toi d'éviter des risques non nécessaires. Donc, évidemment, il va y avoir certains risques si tu utilises des outils. Il y a toujours des risques. Mais le plus possible, tous les points que Patrick avait dit tantôt à propos de la sécurité pendant que tu utilises des outils, s'il vous plaît, utilisez-les. Parce que si vous ne les utilisez pas, je vous garantis que quelqu'un va se blesser, que ce soit toi, que ce soit quelqu'un autour de toi ou que ce soit quelqu'un qui utilise ton robot. Donc, fais vraiment attention, pratique toujours safe build techniques. And essentially, all of this isn't to necessarily scare you. It's more to give you the insight that if you prepare for the worst, then you're able to hope for the best. So if you consider everything that can go wrong and you have a plan to overcome it, then you're probably going to have a great competition.
OK. Ça, c'est la fin de la présentation. N'oubliez pas de vérifier Manager fréquemment pour toutes les nouvelles de la compétition. Si jamais il y a des nouvelles, tu vas les trouver soit sur Facebook ou sur Instagram @RoboCRC. Are there any questions?
Questions, commentaires?